Okay, Assalamualaikum warahmatullahi wabarakatuh, and good afternoon from Jogja time. Right now, I'm recording this record. Now, I will present about my research. It is about the implementation of asymmetric encryption with 250-bit RSA algorithm, timestamp, and nodes in IoT sensor data transmission. And this research is proposed to be in the submission of English task given by Ma'am Nora in the UKRIS informatics study. Okay, about my research, I would like to implement the asymmetric encryption in the data transmission of IoT sensor. Like we know that security has become a critical factor when we are talking about data transmission, or especially in IoT. Uh, every sensor in IoT will send the data to the server, and this data transmission is very vulnerable to the man-in-the-middle attacks or any other type of attack. So in this research, I would like to implement the RSA algorithm, RSA asymmetric encryption with RSA algorithm. Okay. Uh, in this research, I was proposed to use the RSA as the way to prevent man in the middle text. So before we continue about the implementation, we would like to discuss about the sensors data transmission. Uh, this is the sensor and this is the server. The transmission is used by first we will generate public and private key with the RSA algorithm 2058 bit. So every sensor and every server has their own public and private key. So these public keys is interchange between the system, but the private key is embedded to the every sensor on the server. So when the sensor on the server transmitting the data, they will embed the recipient's public key. So in the data and then encrypt together. When the data sent to the server on the sensor will decrypt the data using the private key, their own private key. So the first step was generating public and private key. And then not only embedding the RSA algorithm, we also embed the nodes and timestamp and also signature in order to prevent the replay attack. So replay attack is basically the hacker trying to uh, replay the attack. So they will intercept the data transmit, and then they will change the data. They will manipulate the data using their own, and then send it to server or sensor or any recipients. To prevent that, I propose to use nonce in order to a nonce is some like of number used once. Nonce is actually number used once, which used to prevent the attacker to guess the or to easily manipulate the data. Okay, now what is the result of this? Uh, in order to break down or attacker, let's say the attacker want to break down the key on the transmitted data. Uh, Here we have the Formula One, which is shown that this is the average time, times to decrypt the data by using brute force attack. So they will guess one by one with using their own computational. And below we have the formula. The formula time required to decrypt by using brute force attack is shown is below. Time is equals the average of trying. The average trying is because we are using 258 bit of RSA algorithm, so the average time based on high next yeah based on high next research, it's approximately half of the total number of keys. We have 248 keys, so it generates 248 possible keys. Yeah. Okay, and then the time need is approximately we have here 4.650 to the power of 10 to the power of 590 years. So it's basically a long time with the current most powerful supercomputer right now called Frontier that have approximately 1.1 exaflops, or it is approximately like more than 10, almost 1 million, more than one exaflops, yeah. Okay, it's about 4.650 times 10 power 590 years. Okay, then it is more far exceeding the age of the universe, like Falcon state that our universe is less than the years. Okay, and then for the replay attacks, the attacker must decrypt the nonce code present in the data transmission. So the data transmit is containing nonce, and they need to crack the nonce in order to uh, in order to doing the replay attack. So they need to crack the nonce. So the nonce here we can see in the formula too. Nonce is used to prevent the attack to doing the hacker to doing the replay attack. So basically we need sum of nonce. We need to how many digits of nonce is used when we want to make to prevent this attack. So the scenario is like this: when we want the message is in the 5 minutes validity. So when the message age is more than 5 minutes, so it will be invalid. We need how many nonce digit? Like we are using this formula. So n is represent as a number of digit. Uh, Required number of digit is using this formula. We are using round down, so we must round it down in the log of t. T is represent of desired time. When we want the expiry time is 300 seconds, we can use this 300. And s in the speed of computational. We will still use the Frontier, the latest state-of-the-art supercomputer, and then it's divided by 5, and then plus by 1. Why plus by 1? Because we want more than digit, yeah, more than digit we want. Okay, and then when we assuming that we want the validity is 5 minutes or 300 seconds, and the we are using Frontier with 1.102 exaflops. It's required at least 20 digit of nonce in order to prevent attack. I have made a simple calculation here. So uh, for the 20 digit, and this is the 20 digit, where is it? Okay, this is the 20 digit. At least the supercomputer need 453 seconds to break the nonce. So when we want to validity is under the 300, we can use this 20 digit, because when we use only 90 digit, it's only 45 seconds for the supercomputer to break out the nonce code. When we have 20 digits, it needs 453 seconds. So when uh, when this will prevent the replay attack, because when the computer is finished guessing the nonce, correct nonce, the time is up, so the message is invalid, is already invalid, because we are setting the validity time is 300, or expiry time is 300. So when the computer correctly guess or finish the guessing the nonce, it already expired, so it will be unusable. Okay, from the above calculation, we can conclude that this method is very effective to prevent man-in-the-middle attacks and replay attacks in IoT, especially when the attacker is using brute force. Uh, with the current state-of-the-art supercomputer like in the Frontier with 1.102 exaflops, it will need uh, more than the edge of universe to decrypt the RSA, and also uh, we can manage the validity of the data by using desired digit of the nonce. Okay, and then uh, I will show a little bit about the code. So I have the code here. It is the example. The first step was we will generate the keys. Oh, wait, I'm sorry. I will change the share screen. Okay, here's the share screen. Okay, this is the code. Uh, First, we will generate the keys for each on the server or sensor. Let's say we will generate keys for the server and we'll generate keys on the sensor, and the keys will be saved embedded to the device. This is the case 250 2050 I bit. And then after generate the keys, we would like to send the data. Yeah. Let's say we have data here. Okay, we will send the data hello world. And then this data hello world will be encrypted using this function create encryption data. We will embed nonce, timestamp, and combine data, nonce, and timestamp. And then we will encrypt it with the RSA. Encrypt with the RSA. Encrypt data with the RSA for here. Now, we are using the public encrypt of the, this is the public key of the servers. Server's public key, we will embed our server's public key data, and we will encrypt it. So after the encrypt, we also give our signature. Now this is the important part. The signature is uh, we are having the we are signing the data transmission with the sensor private key. So we are embedding the encrypted data, and then we add our private key here, and we are using the SHA 256. It is we can use another method using the crypto JavaScript to create sign to make sure the authenticity of data transmission. So this is basically in the third layer of security. Okay, we will try this. We will call this function. So this is the encrypted data. This is the data sent to the server, and only the server can decrypt this data. And also this is the signature to check the validity of the data transmit, like this one. Okay. This is the code from the server. Now, when the incoming data come, and this is the encrypted data, we will like to buffer the data in the hex format, and then the signature, we have the signature here, and signed encrypted data. We can also add device ID later. Okay, the first one is to decrypt the data. So the encrypted data will be decrypted using the private key of the server. This is the private key of the server. And then we will decrypt also the data and timestamp. And also we would like to, the first was validation, timestamp validation. So the timestamp is validated when the timestamp, we set the timestamp up to 5 minutes or 300 seconds. So when the timestamp was expired, it will be invalidated. Sorry, this is. And then if the timestamp is verified, we are going to uh, verify the signature. So the signature will be verified using the pairing. We as we know that we are sending with private key, and then we will match the private key with the public key of the sensor. And then if the data is verified, we will save the data. We can use, maybe we can write on the database or anything. And this is I just print the success data record here. Okay, that is the how implementation of this method. And then let's going back to my article. So this is basically very effective to create a security layer using RSA 2048 bit and using nonce and timestamp in order to data transmission of IoT, because it's almost impossible to break this encryption. Okay, that's all of my presentation. Thank you for listening. If you have any question, you can contact me on my email. This is my email. Okay, thank you and assalamualaikum warahmatullahi wabarakatuh.